Our first talk is by Robert Bertin, Katherine R. McKenna, Karen B. Searcy, Matt Hickler, and Glenn Motzkin. It's titled, as you can see, Patterns and Changes in the Flora of Franklin County, Massachusetts, a Progress Report.
This, as the title says, is a progress report on the flora of Franklin County that I am working on along with Matt Hickler, Glenn Motzkin, and Karen Searcy. Katherine McKenna is a recent graduate of Holy Cross who actually did most of the analyses that are going to appear here. Franklin County, there it is. It lies just a few miles to the north of us, runs up to the borders of New Hampshire and Vermont. Occasionally we've gotten into those states by mistake, actually. It runs from the Berkshire uplands on the west, Connecticut River Valley in the middle, to the upper Worcester Plateau on the right. And it has never had a flora done for that county, despite the fact that it seemed to us quite an interesting area. It's got major rivers in it, the Connecticut, the Millers, the Deerfield rivers. It's also got some quite interesting geology with particularly the Waits River Formation that has some calcareous elements to it. What do they call it? Dirty limestone or something like that. Rather rich habitats. Our goals for the talk are to describe the flora, since there has not been a published one, to look for geographical patterns that might exist there, to look at how the abundance of non-native species might differ among the towns and why that might be, to look at changes over time in the flora, and finally to see if there have been any changes in flowering phenology. Since some of this work we're doing involves changes, we had to collect historical data, and this is a slide stolen from Karen Searcy, who will be talking this afternoon. As you can see, the first collections were quite early here, between 1810 and 1820. There were big peaks of collection here in the early 1900s by Fernald and NEBC and his associates. Shortly thereafter by Goodale and his associates from Amherst College. And then this brown here is mostly due to a remarkable woman who was a physics teacher at Deerfield Academy, Roberta Poland. And then, of course, there'll be a huge peak here when we... we used 2000 as the dividing line between historical and recent because there haven't been very few collections in the 1990s or the 2000s. In terms of recent sampling, we've tried to do it fairly systematically, spread our visits out over all the 26 towns. So far, we've made an average of 19 visits over 50 hours per town, over 1,000 records, 685 species on average, and this is the total number of field records to date. This is up through the end of 2014. In terms of some summaries here, historical records include herbarium specimens, the majority, but also a large number of literature records. And you can see that the historical sampling, although it involved fewer records, actually has slightly greater species numbers, okay, than we have found, including, interestingly, introduced species. But that has a lot to do with the fact that Roberta Poland spent an awful lot of time in the Deerfield railroad yards. And these days they spray herbicide there.
Robert, I'm sorry, what are your other species? You've introduced...
Oh, I'm sorry. Those are species that either have varieties that are both native and introduced, or there's some uncertainty about whether they are native or introduced. And the number looks high, and I have to go look at that again. Okay, in terms of what is there, well, you would think that southern New England would be perhaps the most extensively botanized area in the New World, maybe. But we found over 200 new county records there since we began fieldwork in 2010. A number of them are introduced species that probably weren't there previously, but also some native species. I mean, sweet pepperbush is obviously extremely common towards the coast, but it kind of gets over, just nudges into the easternmost parts of Worcester County. Same thing with rhododendron viscosum, and then there are some, somewhat obscure things that might have been overlooked. But in any event, a lot of new species, and we believe we've also rediscovered a number of species that in Kalina's Massachusetts checklist from 2011 were listed as historical. We believe we got this actually just this year. This is a species easy to confuse with Calistegia sepium, probably been overlooked. This is a hawthorn. Say no more. This one, probably some taxonomic confusion with Cerastium arvense. And at least one member of our group feels we have Solidago hispid.
Excuse me?
Yes?
Can someone cut the lights in the front a little bit?
Yes, that would be nice.
Maybe I can. No.
Yes,
Sorry, I can't. Okay, I'll keep talking.
Elizabeth,
Yeah.
this might be a slider over here.
Okay, in terms of regional patterns of the flora, roughly you can divide it into three regions: the western uplands, the Connecticut River Valley, the eastern uplands, approximately like that. And we looked for trends or species that were associated with each of those three regions. We did find a number of patterns. First of all, at the moment at least, species numbers tend to be highest in the Connecticut River Valley towns. That probably owes to the fact that all of the Connecticut River Valley towns also include a bit of adjacent uplands, so they're perhaps more variable habitat. They also have a longer history of human disturbance and probably have more non-native species in them also. Species of rich and calcareous habitats tend to be more common in the western uplands. Here are three examples. That again owes probably to the geology, the Waits River Formation, and I think there's one other formation that has some calcareous elements to it. In the Connecticut River Valley, there are more species of disturbed habitats. This area, of course, was settled first, Deerfield. Longest history of human use, and also these towns have the highest population densities and the greatest amount of altered habitat. So it's perhaps not surprising that a number of introduced species are most common in the valley. Floodplain species, no big surprise there, since they're following the floodplain of the Connecticut River, and to some extent also floodplain of the lower Deerfield and Millers River. Also, species of southern affinities. A number of those tend to be more common in the Connecticut River Valley. Again, not surprising because those are the areas with lowest elevations. If we move to the eastern uplands, you find a number of species that you expect to see in peatlands and other acidic wetlands that are more common there, including these three, also pitcher plants, for example. And you also find a number of aquatic species that are much more common in the eastern uplands. And if you look at a topographic map, you see lots of ponds in that region. If you look in the western uplands, there are surprisingly few ponds, so it's simply a matter of the topography and the hydrology there. Native and non-native species seem to be behaving differently over time. This change index runs from -1 to +1. If it's positive, it means a species has been found in more towns in the recent sampling than in the historic sampling. And you can see that for native species, the peak here, actually the mean, is very close to 0.1, a positive number. And we don't think that means native species are increasing. Rather, we've sampled a bit more intensively. But you can see that non-native species have a markedly different pattern. The peak is pushed over here to the right. And in fact, the difference between these two distributions is highly significant. So non-native species certainly seem to be increasing at the expense of native species. I might add that there probably was also a bit of a historical sampling bias away from non-native species, but I think there's something else going on here too. Okay, looking at non-native species that we find today in different towns, we find a number of variables correlated with their abundance. Specifically, these all have to do with different aspects of human disturbance. All of these are positively correlated with the percentage of non-native species. None of the negative correlations were significant, although not surprisingly, the strongest negative correlation was with the percent of land in natural condition, which basically means forest and somewhat wetland also. Looking at native species now, we found 4 families that seem to have more species in apparent decline than you would expect by chance. 2 of these are found in decline in almost every study that has been, comparative study that has been done, the orchids and the grape ferns and their relatives. These are ribes, and of course there was an active eradication effort against gooseberries and currants because it's an alternate host of white pine blister rust. And violets are a little bit less certain as to why that should be, although several other studies have noted an apparent decline in violets. It could be perhaps a successional phenomenon, I'm not quite sure. I don't know whether deer particularly care for them. I don't know if we can blame it on deer. I will show you a number of maps for individual species, and this is these are the symbols that you'll find on them. That represents a town where that species has been recorded historically and also recently. That's a town where it was recorded recently but not historically. And then these represent historic-only records. So these are two members of the Ophioglossacea, which appear to be declining dramatically. Moving on to the orchids, we could have chosen any number of species here, but a lot of the orchids seem to be in real trouble. There do seem to be some habitat-related declines. Agriculture is a little less extensive than it was, although it's still pretty prominent in Franklin County, and all of these are species of open areas that appear to be in decline. Among the non-native species, you see a preponderance of pluses, and I mean, something like Phragmites we all know about, but there are a number of other species, many other non-native species that really seem to have increased in the landscape. I mean, here's a species that wasn't even listed in Newcomb's Wildflower Guide, which was published, what, in 1980 or something like that, and now you see it in every town in Franklin County. There are also some declines among the non-native species. A few of these are what I think of as garden species that have fallen out of fashion. Okay, how many of you are growing caraway in your gardens? Probably not too many, okay? So we do see some declines among the non-native species. Another category, declines among non-native species, are the agricultural weeds. And this has been noted, it's been noted in Worcester County. It's also been observed in parts of the UK. In fact, there are even societies that wonder whether we should preserve agricultural weeds. I won't. All right, another change that we look for is whether northern and southern species are behaving differently. And you can see that there is a tendency for northern species to be decreasing and for southern species to be increasing. However, the difference is not significant here, but the trend, I might point out, is in the same direction as what was found in Searcy's work in the Holyoke Range and some work that I did in Worcester County. We'll continue to collect data on this point. Flowering phenology. This is a plot of, we looked at just over 100 species that had a mean flowering time before the summer solstice. And if we plotted these points, the historic flowering points, they would be evenly distributed around that line. That is, that was the mean. Okay? But the current represents, the mean has advanced 6.4 days. Okay? The spring flowering species, you can see the vast majority of the distribution is to the left of where the original mean was.
Since when?
The question was since when we took all of the historical records, which admittedly run from the early 1800s to the year, I think actually they stopped this in 1980. The preponderance of those would have been collected in the first half of the 1900s, so if you want a ballpark average, this might be about 70 years. Most of the temperature change in this area has actually occurred in about the last 30 or 40 years. And it turns out, although I did not put the slide in, that the earliest flowering species show the greatest advance on average, and that is a significant trend. So, to summarize here, there are a number of conspicuous geographical patterns that reflect fairly obvious aspects of geology, hydrology, human use of the land. Non-native species collectively seem to be increasing relative to native species, and probably this is a reflection both of introduction of them and also modifications of the landscape that make the landscape more compatible with their needs. These four families seem to have higher rates of loss than the flora as a whole, and finally, spring blooming species, their flowering times have advanced about a week in approximately 70 years. And finally, thanks to all of these people, and this is a view from Sugarloaf, which is in Deerfield looking south. So you're seeing a little bit of Franklin County, and then we're looking south into Hampshire County. Thank you.
Time for a couple of
Thank you
questions.
very much. Yes?
When did you start on this? And
Started field work in 2010, and we're figuring maybe a couple more years, but it's so much fun we may push it out. Frank?
Robert, the Connecticut River Valley towns, just wondering what you think the effect of the basalt ridges is. Is that also driving the diversity trends upward?
Yes, it certainly could. So there is more varied geology there. So good point.
And
Yeah.
are you counting that as a calcareous habitat, or are you?
Well, I didn't specifically classify the habitats as calcareous, but I did classify the species as whether they like rich and calcareous, and that was based on the habitat designations in the Haynes Flora, whether they specified rich or calcareous or whatever. There certainly are species of rich habitats that are very prominent in some of the Connecticut River Valley towns also. Okay, but we also tend to see many of those things in the West too. Yeah. Yes?
Did you look at all at adventive species that have moved further north out of their native ranges?
You mean things that are native just to the south of us, but have kind of moved in? Let's see, I don't think specifically we have. I'm trying to think, I'm asking my colleagues, have we seen anything that's native just to the south of us that we pick up? You're nodding.
Yeah,
wisely.
I think we've got a few, but statistically it's hard to deal with them because they're all anecdotal. But we have things like the Tricularia radiata, which has jumped into the county fairly recently. I think there's some other aquatics that have done that.
Yeah, well, you know, one example we were thinking about, Acer negundo, the actually maple, is a kind of a floodplain species, and it's certainly more prominent further south. It's not considered native in Worcester County, which is just to the east. And I'm uncertain whether it's actually native to Franklin County, because the first herbarium records go back, I think, only to the mid-1900s or the
Even later, Robert.
and you'd think that something that's as common as that is now would have been collected substantially prior to that if it were there. So that's one species that might have moved into the county.
Certainly have data on a couple of woody species like Liriodendron and catalpa.
Yeah.
And catalpa is widespread, Liriodendron is not, but it's naturalized in several locations in California.
Yes?
Could you speculate as to the reason for the decline in the Batricians, the great ferns? Because we're finding the same thing in Vermont, and I don't think it's here.
Well, the leading hypothesis that I've seen, there was a paper published on a rare Batricium in Michigan, Batricium mormo, and they looked at places where it had been found historically, and they revisited them, and in some cases it was still present, and in other cases it was not. And they measured a whole bunch of environmental variables, and the one that had the greatest explanatory power was the presence of introduced earthworms, where it was not. And the idea there, they have an obligate dependence on fungi. In fact, I believe before they become photosynthetic, they depend completely on the fungi for their nutrition. And if the earthworms are breaking down the organic matter, converting more to mull soils, those fungi might not have a food supply, and therefore the Batriciums don't have their food supply either. So that's, although I mentioned that at a seminar I gave one time, and somebody in the audience was from Europe and said, well, that can't be true because in Europe they're declining and all those worms are native there. So, so conceivably there could be other issues or multiple variables. But I've also heard that explanation about for the decline of some of the orchids, because again, the orchids live exclusively underground with an obligate dependence on fungi for several years before they emerge. And if the fungi don't have appropriate organic matter because it's been converted by earthworms, then they might have a tough time getting established. So that's one possibility.
Okay, I think with that, we'll have lots of